we're going to be talking about section 6.1, which is going to be covering GCF and grouping. Okay, these are the most fundamental forms of factoring. That is the main idea for chapter 6. Okay, so before we get into the actual application and the mechanics of this, let's talk about a definition. Let's look at that word factor. Now, factor can actually hold one of two parts of speech. So it could be considered a noun. And as a noun, there's actually two uses for that. Okay? First use as factor is a part of a product. Okay, so if let's say I have a problem, 3 times 2. That's a multiplication problem, but it's also thought of as 3 is a product of that multiplication and 2 is factor. So 3 is a factor and 2 is a factor of that multiplication problem. Okay, another way you can think of it is an expression that divides another expression evenly. Okay, so for instance, I say expression because it could be a polynomial or it could just be a number. I'm just going to stick with numbers for illustration purposes. Let's say we have 12. Okay, a factor of 12 could be 2, because 2 divides 12 evenly. It could be 3. It could be 4. Could be 6. Okay, and don't ever forget 1 and the number itself. Those are all factors of 12. Now, the other thing I want you to notice, these factors come in pairs. Okay, 2 divides 12 because 2 times 6. 3 times 4, 1 times 12. So when you're looking for factors, look for them in pairs, and that way you won't miss any along the way. Okay, so that is factor as a noun. Part of a product, okay, and then an expression that divides something else evenly, okay. Now, the other way we can use factor, let me move over here a little bit, is a verb, and that's what we're really going to be talking about in depth with this chapter. And the verb form of factor, to factor something, is to write as a product. Okay, we're writing something as a product. So let's go back to that 12. 12 could be written as 1 times 12. That is a factorization of 12. I could also say 2 times 6. I could say 3 times 4. Those are all factorizations of 12. Okay, one other factorization, I'm going to ask if you can think of one other factorization. Pause the video for a second and see if you can think of another one. Remember, I didn't say a factorization had to be one number times one other number. Okay, another factorization could be that. It's a product. Okay, 3 times 2 times 2. Notice the 2 times 2 can come from breaking up that 4. Okay, or you could say there's a 2 here and you break up the 6, 3 times 2. This is what we call a prime factorization because it's all made up of prime numbers. Okay, again, a lot of times we are going to be sticking with 2, but I just want you to be aware that there are ways that we can sometimes break things down continuously. Okay, so this is the idea of that word factor. Now let's talk about the actual mechanics of the idea of GCF. Let me clear the board. Now, first thing I'm going to ask you to do is find the GCF. Now, GCF, we should all know, it stands for greatest common factor. Greatest means the biggest, Common means something they have in common, and now factor means, based on that definition of it divides things evenly. Okay, so let's start out with two numbers. Let's say 36 and 42. Just random numbers, 36 and 42. Now I want to find the biggest number that divides both of those evenly. Now a lot of times what people do is they think of a number, because notice these are both even. So 2 goes into them. But you look at that and you're like, okay, I know 2 goes into that, but there has to be something more. And then you just sit there and you think, and you think, and you think. And then you just stop. You just hit a roadblock, okay? And you forget what you're even doing. So what I would suggest you do is, if you can think of a bigger number right away, go for it. But after maybe 5 seconds, if you can't think of anything else, take the first number you see out, okay? So for instance, they're both even. I'm going to take a 2 out. Now when I say take it out, I mean divide it out and see what's left. So 36 divided by 2 is 18. 42 divided by 2 is 21. This is the common factor. This is just there to help me check and verify that nothing else is there. Now notice, 18 and 21, they're not even anymore, but 3 goes into both of them. So what I'm going to do is I'm going to take that 2 down, but then also take out a 3. If I take out multiple factors, multiply them. Okay, so if I take that 3 out, I get, not equals, I get a 6, because 18 divided by 3 is 6, 21 divided by 3 is 7. Now I can see 6 and 7 have nothing else in common. 2 times 3 is 6. That is my GCF. Okay? So, let's move on. Let's look at 35 and 44. Okay? Now, if you're looking at that and you're kind of stuck, I want you to make sure that you have covered all your bases before you just say, okay, that's it. There's nothing there. Okay? Pick one of these numbers and list all the factors that they have. So let's say we go with 35. 35 would be 1 times 35. Okay, again, a factor pair idea. 2 doesn't go into that because it's not even. 3. If I want to know if 3 goes into a number, 3 plus 5 is 8. 3 doesn't go into 8, so it doesn't go into 35. Okay, if 2 doesn't go into it, no multiple of 2. So if I know 2 doesn't go into something, 4 definitely will not. 6 will not. 8 will not, and so on. So 4 doesn't go into that. 5 times 7. Okay, notice I'm doing this sequentially. I'm not jumping from 1 to 10 to 3 to 13. 1, 2, 3, 4, 5 hits. 6, remember it's not even, so 6 isn't going to work. And then I hit 7 again. Once I repeat myself like that, I'm done. There's nothing else to check for. These are my factor pairs. I have 4 factors for 35. Do any of those go into 44? The only thing that will always go into everything is 1. There's your GCF. Okay? We would sometimes call these numbers relatively prime because they have no common factor besides a 1. Okay, they're not prime numbers in and of themselves, but they're relatively prime to one another. One more like this. 12, 16, 40. Same idea, we just got 3 numbers. Same as before though. Look at it, they're all even. So definitely 2. Don't sit there and be like, oh, I think another one, I think another one, I think... Just take the 2 out. Why not? Okay, so I'm going to take a 2 out, and I'm left with 6, 8, 20. Okay, now I can see that these are still even. So I'm going to take another 2 out, multiplying those together. And I got 3, 4, 10. Now, 3, 4, and 10. 4 and 10 have something in common, but 3 doesn't. That oddball out, we can't take anything else out. So what we have as our GCF is 4. Now guys, I'm pushing the take a 2, then take another 2, take a 2, then take a 3. I'm pushing that just so that you see that it's a possibility. But if you look at it and say 6 goes into both of these, 4 goes into both of these, or all 3 of these right at the get-go, go for it. If you can do it in one step, great. But if you're not there yet, don't be afraid to take it in multiple steps. Okay? Next thing I want to talk about is variables. Okay, we talked about numbers here. What happens when there's a variable involved? Let's say we've got that, okay? Now, with this, they all have x's in common. When there's exponents involved like this, what you should be looking for is the smallest exponent that they have. Because remember, when we take a GCF out, we're dividing. But with exponents, division actually carries itself out with subtracting the exponents. So we're not looking at what divides a 3, a 5, and a 2. We're looking at what can be taken away from a 3, a 5, and a 2. And that's the smallest exponent of 2. Okay? So all I would do is take out that x squared. There's your GCF. Now, if you want to put the parentheses to show the leftover just to double check, how you would do it is, again, subtract 2 x's from each. So 3 minus 2 is an x to the first, or we just write an x. 5 minus 2 is x cubed. And now when all of that goes away, remember, anything divided by itself is just a 1. Okay? So again, this isn't as necessary because you're just taking the lowest number. But if you want to verify, then this is how it would look as your leftovers. Let's do one more like this. Let's say we have we got that. Okay, now there's more than just one variable involved, but same idea. Notice we have 3 different terms, okay? They all have x's to give. So x is a GCF. The smallest exponent we see on an x is this 2. So that's part of my GCF. How about the y's? Do they all have y's to give? Yes. The smallest exponent we see on a y is that 1. So y to the first. And then finally the z's. Now notice z's, this doesn't have a z. So if they don't all have z's to give, it can't be something common that we take out. So our GCF is simply that. Okay? Now that is it for determining what a GCF is. Now let's actually factor, meaning write as a product using a GCF. Okay, so when we're factoring with a GCF, let's start out with something simple. Let's say we've got 4x plus 12 as a binomial. Now what we were just doing would have looked like this. Okay, all I'm doing is making it mean something now. We're pulling it all together. Now, what is the GCF between a 4x and a 12? Well, they're both divisible by 4. Okay, so I would take a 4 out. Now, the reason why I had you put that leftover stuff in parentheses before was to check, to make sure there was nothing left in there that could be taken out. Here, though, it's absolutely necessary that you put that in there because now we're going to see that as a product. We're undoing distribution, essentially. So if we take a 4 out of that, we got x. 12 divided by 4 is a 3. Okay, you don't need that little dot there. And there we go. We took this sum and we wrote it as a product. There's 2 ways that you can check this. Okay, two things you need to check for, I should say. First of all, make sure there's nothing left that they both have in common. Okay, also redistribute. And you don't have to write this down, but just get in the habit of 4x, 12, bingo. Okay, those 2 seconds that it takes can really save you a lot of headache later if you catch your mistakes right away. Okay, so there's your first example. Let's look at another one. Now what a lot of people do is they want to go after this negative out in front, which you absolutely can, and I'll show you that in a second. However, if taking a negative out is not going to help you, I really wouldn't bother, okay? So what I would do here is, forget the signs, just look at the terms. All of these are divisible by 3, and they all have an a to give. Okay, there's my GCF, but I have to write what's left over. So if I divide each of these by 3a, I got negative 3a to the 4th plus 6a minus, don't forget, a 1. That 1 is absolutely necessary. If you don't have that, remember, you should be able to distribute this back. There would be nothing to distribute back to get that last term. So that has to be placed in there. Okay. Again, to verify, nothing else in common. 9a to the 5th, 18a squared, negative 3a, we're good to go. Okay. Now, if you want to take the negative out, all I would do is take a negative 3a out instead. That's it. Okay. And when I divide that negative out, all that does is change all the signs that were left. So it would look like this. Unless they specifically say to take a negative out, there's really no preference over these. When we get into trinomials in the next few sections, I would suggest you do this just to make the rest of the problem easier. But to take a GCF out, one is not really better than the other. Okay? Now that is factoring using a GCF. Now let's expand on that a little bit and get into what's called grouping. So let's factor using grouping. Okay. Now grouping is primarily going to be utilized when we have 4 terms. Okay, GCF can and should be used anytime you see a problem like this. Okay, I don't care if it has 2 terms or 150 terms. Okay, but grouping is primarily with 4 terms. It can be used with 4 or more terms, but it has to be a very specific type of problem to use it with 5, 6, 7 terms. With 4 terms, it works pretty often. Okay, so that's why we stick with 4 terms. So let's look at one. Let's look at this, okay? Now, first thing that I want you to always look for, is there a GCF with all of them? And in this case, there is not, okay? So what we're gonna do with 4 terms and grouping is we're gonna basically divide and conquer, okay? So the first thing that we're gonna do is when we see these 4 terms, I'm gonna group first 2, last 2. Now notice, if I walked in right now and I saw this, what would you do? You would drop those parentheses, okay? So I didn't change anything about the problem by doing that. I just pushed them aside, okay? Now, instead of, is there a GCF with all 4? Is there a GCF just with these 2? Yeah. I'm going to take out a y, and I have x plus 3. All I did was GCF, okay? I'm going to do it again. I could take out a 4. And look at what we have. Now, this is still not factored because it's still a sum. But if you notice, these match. If those match, this is how we pull it together. I take these GCFs and I create a binomial. And then I take one of these down, and this is my factored form. Done. If you want to check, make sure there's no GCFs with either of these, and then I would FOIL it. I got xy, 3y, 4x, and 12. And everything's good. Okay, now why are we doing it this way? There's a couple ways you can think of it. In the book, they tell you to think of these x plus 3's as GCFs themselves, and you pull them out. And that's what gives you this. Another way that I like to think of it, think of 3x plus 5x. You don't even bat an eye at that. That's 8x. Okay, but why is it 8x? Because you took 3 plus 5, and then you carry down that x. Same thing I did up here. So I've got my 8x. Okay, so it's the same basic idea as combining like terms. Okay, so that is factoring by grouping. Let's look at a few more of those. Let's say we've got now there's something very unique about this problem here that we need to pay attention to. We have 4 terms and there's no GCF with all 4 of them. First things first, okay? But you see this negative here. Do not group like so. Because if you do that, and then someone walks in right now, they would distribute that negative. Okay, it started as a negative 3x, but then it would change this to a positive 4y. We just changed the problem. We can't do that. So what we should do first, before we group, is rewrite the problem. What I mean by that is, instead of minus 3x plus negative 3x. Same meaning, but now I can group safely. Because this is still a negative 3x like we started, and more importantly, this is still a negative 4y like we started. And now we're back to business as usual. So, GCF here is an x. Now notice here, remember what I said about negatives. Only take them out if it's going to help you. We want these to match. Right now they don't match until I take a negative out. So I'm going to take out a negative 1 to change the sign but leave the terms alone. And look at how nicely those come out. And then what I get is an x minus 1 and a 3x plus 4y. And there we go. If you write the problem as 3x plus 4y then x minus 1, totally fine. Okay, we have that commutative property of multiplication that allows you to switch around the order. Okay, let's look at a couple more. Okay, so on this problem right here, we would first of all start no GCF with all 4. But there are 4 terms, so that would lead us to grouping. So I'm going to group, remember, change that sign and group. You're not even really changing any sign, you're just writing it a little differently. Okay, now let's try the grouping. Now notice, there's no GCF. Over here, besides a negative 1, there's no GCF. If we took the negative 1 out, that doesn't allow anything to match. So the grouping doesn't really work here. Okay, now that doesn't mean all is lost. That just means maybe we need to try a different grouping. So what I like to do is rearrange this by switching the middle 2 terms. You can technically switch the terms any way you like, but what I see people do sometimes is they switch them so much that you just repeat what you just did. So what I like to do is switch the middle 2 because that guarantees a different outcome. Okay, so I'm going to rewrite this. I got 4xy minus 12x plus 15 minus 5y. Okay, same problem, just ordered differently. And now I group again. Okay, this is a different result now. What's your GCF here? You can take a 4x out to get y minus 3. Okay, now be careful here. We see 15 and 5, so normally we would just go take a 5 out. That's perfectly fine. However, these don't match. Okay, so they're pretty close, but they're opposites. How can we fix that opposite issue? Don't take out a 5. Take out a negative 5. And when I take out a negative 5, it's negative 3 and a positive y. Now these are the same. Okay? They're switched, but they have the same meaning. And once I get that, I get 4x minus 5, y minus 3. Again, if you want to check, make sure there's no GCFs within these, and you can FOIL that back to get the original problem. How about this? Okay, so first of all, no GCF with all four of them. Okay, so then I go into grouping since there are four terms. Okay, this right here, I would take out a 9. So I get a y minus 2. And then here I take out a y squared. And I get a y minus 4. Okay, that worked out nicely. However, these don't match. So again, that doesn't work. And this is not factored because it's still a sum. So when that original grouping doesn't work, switch the grouping. So instead of that, I'm going to switch these to get a 9y plus y cubed minus 18 minus 4y squared. Before you move on, you make sure you wrote everything down correctly. Okay? Now, I'm going to try grouping again, but remember, adjust first. Then I group again. Okay, and I cover that plus sign up, but there's a plus sign in between. I can take a y out to get 9 plus y squared. Here, I can take, they're both negatives, let's take a negative out. Negative 2 to get a 9 plus 2y squared. Okay? If you're a little shaky with factoring out those negatives, when you think you need one, redistribute. Negative 18, negative 4, just to verify halfway through the problem. You don't have to check at the end. If you check halfway through, that's a good thing because you don't want to go through a bunch of steps and realize at the end that it's all wrong. So check as you go. Now, if you notice, these don't match. So the original grouping didn't match. We switched the middle two, didn't match. There's no other grouping that is going to work. Okay? So when you try the first arrangement, doesn't work. You switch the middle two, doesn't work. You just can't factor it. Okay, now what the book says is cannot factor by grouping because there is a method that we can use to factor this that you'll learn in like a pre-calculus course. But for our purposes right now, I'm okay if you just write prime. But again, in like my math lab or in the book, they're going to say cannot factor by grouping. Okay. Now, one thing, just a word of warning. When I show this to people, a lot of times they look at a problem, they're like, it doesn't look like it's going to work. Can I factor by grouping? Okay, or they just put prime. Make sure you try everything, because sometimes it doesn't look like it's going to work, and then it does. Okay, the other thing is, don't look at a problem and say, oh, it's going to be nicer if I flip these. Sometimes it's not so nice when you flip it. Okay, so I would try it as it's given to you first. Prove that it doesn't work before you flip anything, because sometimes you flip it because you think it's going to work nicer, and that causes it not to be able to be factored. Okay, so try grouping. If that doesn't work, then you flip those middle two. Let's do one more to finish this up. Let's look at that. Now, there's something different about this one. Is there a GCF with all four? Yes. Do that first. Okay, so I'm going to take a 3 out of everything. And we got that. Now, like I was saying before you move on, redistribute. You don't have to rewrite anything. Just in your head, 3xy, negative 3ay, negative 6, positive 6. Okay, good. Make sure that's right before you do anything else. Don't wait till the end to check. Check as you go. Okay, so I took that GCF out. Now, I still have 4 terms that I need to group. So I'm going to bring down this 3, and I'm going to write this pretty big. Okay, just so I can visualize the different layers of the problem. Now, to group this, Don't forget that adjustment in the middle. I am going to take out a y to get x minus a. Then here, I'm going to take out a 2, okay? Now, 2a, I'm sorry. A lot of times when you see a negative out, people want to just take the negative. Let me show you what happens. Negative 2a, and I've got x minus a. Okay, let's just verify. Negative 2ax, positive 2a squared. These match. Okay, so again, when you have that negative in front, a lot of times take it out as part of that GCF. There will be times where you don't want to, but again, if you take a negative out and you're like, oh, these were opposites, put it back in. Not a big deal. Sometimes it is a trial and error type of situation. So what I do to pull this together is y minus 2a and x minus a. Okay? Now, I'm going to ask you this. Why would I mark that wrong? I forgot that GCF that I took out in the beginning. That has to be part of your answer. And that would be my final result. Okay? So, again, we started with what does it mean to factor? That's what we're going to be working on through this whole unit. Then we talked about just GCF in general, which can be applied anywhere and everywhere if it's there. And then we specifically looked at 4 terms at a time with grouping. Okay, as always, if you guys have questions, please feel free to reach out. Keep working hard, keep at it, you'll do great. Good luck.